In this video, I'll focus on the geometric concept of area of perimeter problem. So I'll first highlight a brief overview of this concept and then go through some practical problem solving. So let's dive into the video. I'll focus on the first problem of the area of perimeter problem concept. So let's read the problem. It says the diagram shows one face of a wall. The face is in the shape of a pentagon. So the face is in the shape of a pentagon with exactly one line of symmetry. So Omondi is going to paint this face. So this is one face of the wall. So he's going to paint the face of the wall once. So he has to buy all the paint that he needs to use. So the paint in each tin of paint Omondi is going to buy will cover 16 meters square of the face of the wall. So one tin of paint costs 16 meters square of the face of the wall. So you have to work out the least number of tins of paint Omondi will need to buy. So the least number of tins of paint that Omondi will need to buy. So you have to show your working clearly. So in order to figure out the least number of tins, we have to figure out the surface area of this this face of the wall. So we have the value of the edges of the pentagon looking shape of the wall. So we have to figure out if I draw a line here, a straight line here, horizontal straight line, it will divide into two parts, a triangle and this rectangle and this triangle. So we can individually figure out the area of these two parts and then add up, so to find the total area, and then we can find the least number of tins of paint that Omondi is going to require. I'll draw this diagram to show how you can calculate the total surface area of this particular face, and through the area you can find the number of the minimum number of tin of paint that Omondi required. So if I just draw this pentagon, so let's just draw this pentagon here with, let's say, this, then let's just look at the diagram again. Okay, this and this. So this is the pentagon. Okay, let's just give the edge values, which is 7. This is 7 meters, this is 7 meters, and this is 6 meters, 6 meters and 10 meters. So this is 6 meters, 6 meters and 10 meters. So what we can do here is we can connect this one. Let's just my drawing is not perfect, so let's just connect this one. So this is the same as this edge, so this is 10. Okay, so if I need to calculate these two parts, which is the area of this triangle and this rectangle. So how can I calculate the area of this triangle? Let's just name it, or maybe if I calculate if I draw a perpendicular, as you can see, I can then use the formula of the area of triangle to figure out. So this is 90 degrees, obviously this is also 90 degrees, and 7, these two are same according to the diagram. So if these two values are same, then what I can do here is, because this is perpendicular, so it divides the edge equally. So this is 5, this is 5, even though my diagram is not correct, but still the according to the calculation it will have 5 and 5. Okay, so I know the hypotenuse and I know the base, so I can figure out the height according to the formula of Pythagoras, because this is 90 degree. So the area of this, so let's say this perpendicular is x. So x is what? X is 7 square minus 5 square root, which is what? Which is root 49 minus 30 5 square is 25, sorry, 5 square is 25, so 49 minus 25, or this is also root 24, so 24 can be written as what, 4 into 6, so this can also be written as 2 root 6, so 2 root 6 is the value, so the value of x is 2 root 6, so if the value of x is 2 root 6, then I can find the area of this part. So the total area, let's say the total area is t, so of this surface, of this entire face, so the total area is the area of the triangle, which is half multiplied by the base, which is 10, multiplied by the height, which is 2 root 6, plus then the area of the rectangle. The area of the rectangle is 10 multiplied by 6, which is 10 multiplied by 6, so I get what? I get 10 root 6 plus 60, so this is the total surface area. So if I use so 10 root 6 plus 60, so I can do the approximate calculation of this part 10 root 6 plus 60 to figure out the total minimum number of tin cans that Omondi required. So if I just use my calculator, so I can use the scientific calculator to figure out 10 root 6, so 10 multiplied by root 6 equals plus 60 is 84.495. Okay, so this is equal to, this is approximately 84.495. So what is the least possible number of, what is the least number of tins Omondi requires? So the one tin can cover 16 meters square, so if I divide this by 16, I'll get, if I divide this number by 16, I get the minimum, I need minimum 5, minimum approximately 5, minimum 5 tin cans is required for Omondi to cover this face of the wall. So this is how you can calculate the minimum number of tin cans that Omondi required. I hope by now you have a good idea by analyzing this problem that how you can solve the area of perimeter problem. So in the next video I'll focus on some more problems, so stay tuned for that.